Let's try to solve this integral. So we're given ln of x squared, y squared over that. And we're trying to integrate this over this restriction where x squared plus y squared is from 1 to 100. And we should know that this kind of represents the equation of a circle. We can kind of get two equations of two circles from this. X squared plus y squared equals 100, which is technically 10 squared. And then x squared plus y squared equals 1. Which could be represented as 1 squared. So we kind of have two radiuses here. This will be radius 1 and radius 2, which is obviously just going to be 1 and 10. So this is one idea. And let's look at this and realize that, hey, look, we can actually just represent this x squared plus y squared stuff as r's. And so if we want to try to integrate with respect to r's and thetas and stuff, we're going to want to be using the polar system. So with that in mind, keeping in mind that like a double integral with a polar expression, you're going to need to do a dA. And in order to get the dA is supposed to be r dr d theta. So let's consider that. We have to include the dA into this. So first, let's replace this stuff with r's, because we know it should be like ln of, well, x squared plus y squared is supposed to be r squared. So we're going to do that like r squared. And then we also have the same r squared on the bottom. And then now we kind of have this where we're going to be integrating the expression, but we still need to add the dA. So let's not forget that. So we're going to put r dr d theta. That includes an r there. Now the cool thing is those r's are going to cancel, so we're going to have kind of like this double integral. And let's figure out where these two are supposed to be, because on the outside you'd have the thetas, and so theta would be going from, if they're circles, keeping in mind they are two circles, it's going to go from 0 to 2 pi for the circle. And for the r's, we're going from 1 to 10. So r equals 1 and r equals 10. So we kind of have two integrals. Remember that the r has to be on the inside for these. And then we're going to go ln of r squared divided by r. And then dr d theta, because we did cancel these two. Okay, so we're making some progress. From here, first we have to integrate the inner side. And because we have an ln of r squared, I'm going to make a u sub. U subs are good for like ln's and stuff. Let's do that. ln of r squared. If we take a du of this, then we'll get 1 over r squared, and then times 2r on top, and then dr. And so then we could see that these will cancel, and we'll get that du is equal to 2 over r dr. Now this is helpful. Let's divide the 2 out. So we'll have 1 over r dr. That's going to help us later, because if we make the replacement, let's try to figure out what this would be, because, well, u equals ln of r squared, so we could do that. Let's just go down here, I suppose. So we'll have from 0 to 2 pi, and then from 1 to 10, and we are making a u sub here. Now, I'm not changing these limits, so let's just be careful of that. So you don't have to change the limits if you do this properly. We're gonna do it right. So anyway, so u equals ln of r squared. U is on top, and then on the bottom we're gonna keep the r, and then we're gonna have the dr d theta here still. But notice that dr over r is just du over 2. So let's get rid of this and call it du over 2, and we'll still have the d theta there, but I had to move it. And okay, great. So now we can actually make the integral, because now we'll just have u divided by 2, and we're integrating that. So keeping in mind, we have to do the inner integral first before we do the outer one. So we're just going to go u squared over 4. That's the answer for that. And before we actually solve this from 1 to 10, I'm going to make the replacement into r's again, because I happen to know that u squared is just ln squared of r squared. Okay, so yeah, I'll just square that. So we kind of get ln of r squared squared. All right, so I'm just putting that right there. Then we're going to divide that by 4. So now that we're back in terms of r's, I'm going to use my r's. That's 1 to 10. And this is going to equal like a ln squared of 10 squared. And then divided by 4. But realize that these 1s, if I start plugging 1s in here, this will just go to 0, so there's nothing else. Minus 0 at the end. So we're pretty close here. Now, 2 is going to move over to the other side of the ln, because you know the properties of logs. We have the ln of 10 squared, ln of 10 squared, parentheses squared. This 2 can still go to this other side here, okay? So we're taking it out of the inner parentheses and moving it to there. Just be careful, there's 2 different squares here, so we have to be sure that we get the right square. We're going to move this square to the other side here, and we're going to kind of get this expression 2 ln squared, or 2 ln of 10, and then this whole thing is squared, divided by 4. This is still the inner integral here. We still haven't done this 2 pi to d, or this d theta stuff, but we're not done simplifying the inner term. You're going to get like a 4 ln of 10, and then this is a squared in there, and then there's going to be a 4 on the bottom. This will cancel. So now you can actually do the final integral here, which is just going to be multiplying this thing by theta. So you kind of get like ln 10 times theta in there. And then, of course, the theta is 0 from 2 pi. So 0 to 2 pi gives us the answer of ln squared 10 times 2 pi. And that is the final answer. 0 at the end.